All right. So this is the rapid prototyping session on the on. Oh, just a moment. For some reason, this is gone into funny mode. There we go. Yeah. So rapid prototyping. This is actually a good set. What the prototyping is usually used for, and basically for you guys to avoid making the biggest mistake all the engineers are always doing, going to the implementation phase before actually you should do the prototyping properly. So, and there the rapid prototyping is basically it's not a technique, it's more like an ideology of how things should be done fast to move on rapidly. And the basically for this prototype, there is one, that's Ulla Sederlöf's idea or definition, experimental model of your idea or concept. So it's not a prototype or a it's not actually a kind of the model zero for engineering for the final product. It has nothing to do with the final product yet. It's a quick way to visualize and test the features what your final product actually would need. And its basic idea is to make your ideas and thoughts tangible, something that you can, put your hat on. Okay, and another one, easy, efficient, and fast. Okay, and basically the idea is also to clarify the development process, so it's not kind of fuzzy gray area where you are just struggling until done, but more like do testing fast, make observations, move on. Okay, so here I have some prototypes actually. The first one is on my own favorite, so that's Antti's Lure 3D model and finished photo or prototype. That's part of the say fast prototyping. The next one from that one is basically the my second prototype of that one. It's electronic lure. It has some microcontroller inside. It has a battery inside, and it has the also the mobile phone vibrator inside. So the idea is to basically run that vibrator once in a while to attract predatory fish, and it works. It took something like 2 weeks to do that first prototype in the middle. Then basically designing of that second generation prototype, which is then printed on plastic, 3D printed on plastic, and the design took something like 3 hours. 3 hours for that that plastic part. About 2 hours to do the this electronics part. We also have some devices here to make the PC boards, or printed circuit boards, and it takes about 1 hour to produce those circuit boards, maybe half an hour to put the components on it. So in total, well, the printing of that 3D plastic model was something like 3 hours. So, but anyways, so using these modern tools actually cut down the prototyping from 2 weeks to 1 day. It's doable in 1 day. So selecting a tool. Okay. Anyhow, that's still on the basically I need to do at least 2 or 3 circulations whenever I have time to do it. Basically it follows about the same idea as there's that model of that elephant holding a mobile phone. I could say it from the beginning and that wouldn't work because of the center of gravity is way too much in the front of that elephant. I can see it already on the design. But that was actually a student's work, so basically they found it the hard way. They printed out the model as, okay, notice there's a fault on design, and they added those tasks on the design, and now it works. Yeah, although it was kind of more like a luck, since well the elephants have tusks. So if they didn't, well, okay. Fortunately, it wasn't a hippo. All right, but anyways, so those are kind of the engineering, 3D modeling kind of things that can be done, engineering prototypes. But then when we talk about, say, the software, then the quick prototyping actually means the paper and pen. On the left corner there is basically the two views views of the design when it's done first on the paper and pen, and these are actually almost the last prototypes here. So the first one, you know that it has been a little bit crappier. So it's just sketching and a lot of black ink on top of each other, maybe 10 or 20 different papers. But that's fast to do on paper. Think of this doing the same thing on software. So never underestimate the power of pen and paper. So for doing fast things, basically this user interface design should start with the piece of paper and a pen. Best way, believe me. It has been proven so many times. But still, as engineers, we tend to start with hey, we have this new tool, let's try this one at the same time. No, it doesn't work that way. Okay, but anyways, that's the memory game, which was done here by a student group and supervised by Ulla Söderlöf. Okay, cannot actually go forward without talking about this kind of the empathy-based prototyping, which is basically it has a funny name. It's not almost nothing to do with the empathy itself, but that's the name of this method. But it's fundamentally it's deep learning what the customers need and basically analyze it to get the insights. So basically you need to do a lot of research within the customers, interviews, maybe with the fast prototypes, get them to give them that piece of paper and say, what do you think about this design? They have an opinion. Deep learning that one. Okay, and based on that information, you just start just setting development ideas and doing the fast prototypes more. And this is actually an ongoing kind of or emerging method, especially when you are doing a co-design with customers. The old-fashioned way was that engineers designed things, or actually first someone, usually the salespeople, pre-sales people, asked customers what they need. Maybe I should actually draw a picture of that one. So how it used to be in good old times when engineers did only engineering, and that wasn't that good time either. Oh, that way. So that was the pre-sales, uh, into the customers and giving the information, design parameters to the engineering team, and then basically, with a good luck, back to pre-sales, we did again some customer service, but usually it went directly to the production. Then we went to marketing. And after marketing, basically you get back to the customer. So customer started at that point contacting. Usually the information went also backwards. So customer gave feedback to marketing, marketing back to production or engineering. Okay. Not too cost efficient way. Now basically pre-sales and engineering team will do the co-creation with customers. So basically there's a direct link between engineers and customers. Yeah, that's how things have changed. Okay, but anyway, so that's empathy-based prototyping is about that kind of prototyping. The funnel model, it's kind of absurd. In this method, basically prototype is not about taking all the information and squeezing everything out, but it's more like a set of filters. You filter certain the wanted material through the filter and you throw the most of the stuff out. All right, more about the prototyping. All right, so there's a lot of methods and tools. Anyways, they more or less every one of those prototyping concepts thought more about circular kind of things. So ideate, concept, plan, implement, test, evaluate, and do that on loop until you have something finished and publish it. Yeah, sure. There's actually, especially on the service design. Service design, there's a really nice tool set. It's basically a bank of different methods you can use if you are planning a service, like any mobile service. It's a service. It's not about technology. It's about doing some value for the customer. So it's service, software as a service. Okay. Then about categorizing the prototypes, low versus high fidelity prototyping, and where's the line between low and high? Well, there's no such thing as fine lines. There's always the gray area, but those are the extremes. Sketch, like pen and paper sketch, that's very low. Yeah, and then when you go to the highest end, you have so-called native prototyping, meaning that you already have the most of the functions are on the platform are really real functions, and they are functional. And which basically means on the high end, or for example mobile applications, you would have a mobile application actually running there on demonstration mode, but still say at least one step to the Play Store. So it runs on your device, and then basically the customer can check it. On the other hand, you can still do the mock-up prototyping if you are depending on what you are looking for. So this high-end prototyping is usually used to test the how this subsystem integrates in the bigger picture. If it's actually technologically feasible to run it on this device itself, or should some of the parts run on a cloud, for example. But for customer point of view, customers don't care about technology. They think also only about value, what the product gives them, whatever the product is. So this low-fi prototype means then that you have the same thing on mobile system or this example system, but you don't have all the functionalities actually there as per se, but more like just a simulation. It's quite easy to simulate, for example, clicking some button, something happens. If actually, the easiest way probably would be to build a web page and put some of the functionalities or mock-up functionalities on that web page, and then just open that page on a browser window on the mobile phone. It's almost the same as the final app. Okay. But anyways, anything in between Sketch and Hi-Fi are considered kind of prototypes. This is my favorite. Pen, paper, and scissors. If we take another look back on my own electronic lure design, I'll show you how it actually started. Let me turn on this back to the cam only. Okay. I did this one on paper, although the whiteboard is as good. Most important, it must be something that's it's just a media where you think. I have been building my own lures, fishing lures, for 43 years. Okay. I know something about it. not everything yet, but still I know something about it. So this I already found out 43 years ago. Electronic lure, any lure or this kind of wobbler has some basic things like the basic shape is kind of a long oval which resembles a small fish. Coloring is just on the surface, but the first ones I took just a knife and then just carved some wood, and then I found out, okay, it needs a link here where you tie the fishing line. Actually, I use a lock there, but anyways, the fishing line is going there. Then it must have something to hold these the hooks. These are holding the hooks. Okay. Then what makes this one to wobble is actually have a plate like that on the front. So basically, this makes this when you pull it with the line, it makes the movement unstable, meaning it starts wobbling like that, and the fish thinks, there's a nice meal for me. Couple of things that I learned after a couple of first mistakes was that actually this wire must be like that. So in case I get a big fish, none of these actually take off. Okay. Then I started working, okay, how to put some electronics inside of the lure. Since it's quite big and electronics is small, okay? And the first idea was just to put some blinking lights, but I had already found out, okay, the predatory fish are interested mostly on injured fish. This makes nice kind of, it's unstable, but it's basically has some the fundamental frequency. So it does not look like a injured fish yet. What you need to have is a vibration of some sort of, so it looks like a fish which is actually somehow injured. So I thought, okay, I need to put a mobile phone vibrator motor here, which means that I need to have some CPU here. Okay, and then I need some battery and some other electronics, and all of this actually go quite nicely in one circuit board, like that. Then there's a problem how to get battery charged. You don't want to actually have any charging wires sticking up out. However, this is actually metal. Only thing what I needed to do on my paper prototype was to cut that one. So I just cut that one loose, and now I have separated this wire from the other one. I can now adjust battery. And this was done on paper prototyping. I didn't do anything before I made this one, and then I started testing it on real life. Yeah, simple. So the same thing actually moved into this mobile world. There's a real, okay, that looks like ATM machine on the top right corner. So that's a nice paper prototype of a machine that, well, probably either gives or takes your money. Okay, maybe both. Yeah, and yes, that's actually a real paper prototype of a real ATM machine. And there you have basically a lot of flexibility in this paper and pen and scissors. Let me turn the cam that way now. All right, so it doesn't show really well, but anyway. You can, of course, you can draw in here. Draw something. In addition to drawing of paper, you can always start, folding it, making 3D structures. So basically, then you need some scissors. Okay, something like that. I lost my glue, but duct tape. And suddenly you have a prototype of some safety switch or something like that. And very tangible. It doesn't need to be more sophisticated than this one. The idea is to actually test if you want to have the button on the middle or somewhere else should be on there. This will give you the correct answer. You can put it on the real place and just try it out. So the fundamental idea is like that. Okay, and then basically the same thing. Same thing, but on digital prototyping. So basically, then we go into mock-ups and using general graphic tools like the Paint, for example. just to make what it looks like. And with the digital, you can actually have the real feeling of the final product there, the final colors and everything there. And there we have a list of some tools for that kind of, if you are planning a digital service like Pop, Sketch, InVision, Graph, there are plenty of good tools there to actually do the design or prototyping. Native prototyping usually requires a lot of programming, so it's already quite close to the product. But before that one, there should be tons of paper prototyping and some digital prototyping done before going into the native prototyping. So native prototyping is a little bit more time consuming, and it's not necessarily any more rapid prototyping. Okay, another one, since the usually, well, every single product in the world has some usage. Let's put it this way. This is one way of doing the prototyping, or one tool to help you with the prototyping is the storyboard. So that's a real example of the first few pages of that. Actually, there's a link to the full thing. Storyboards meaning storyboard is just a cartoon of what happens next, basically. So this one is part of the instructions of on a simple device to monitor babies. Just few first steps, and this actually when you're talking with the customers, you cannot tell actually them. Usually it's no words of telling them anything about technology, what is used. They are not interested in that one. They are interested about the value. Another thing would be, how do I use it? So making the storyboard like that one actually would help the customer to think, okay, this gives me a lot of value to my whatever I'm doing, whatever your technological solution would solve, how this device solves the customer's problem. And storyboard, excellent method for that one. Another one, the kind of journey maps, but this I would say, if you are selling from engineer to engineer, it's at least the right hand side, the check-in, assessment, treatment, outcome. So there's a flow chart there. Okay, if you are selling some products to engineers, maybe you could use flow chart. I wouldn't use it otherwise. Maybe some business people also, if we understand the flow charts, but this is not common. This is not commodity to actually have this kind of journey maps on a flow chart form. But yes, kind of different. There's a journey map given on some, what is that? Research, enter, use, enjoy, exit. Yeah, kind of having also this kind of feeling kind of things involved there. Yeah, sure, why not? But it's oriented graph that describes the user, the journey of a user by representing different touch points that characterize the interaction with the service. So yes, so this basically, if you have a digital service, for example, on eBookers is a nice example. So you are basically making the planning of the journey. That's one touch point, and it's quite important that me as a normal user of the system, that it's easy to find out for example, which hotel is the best one for my purpose on all of those million hotels available. And I want also the best price, but I value more the easiness and effortless than the best price. So I can pay, say, something extra. So okay, that kind of things that actually should be taken care of these user journey maps. How do I feel and what I'm expecting from the system and or the service. So basically, there you should think the whole timeline of your product, how the end user will interact, about the feelings. If it gets kind of too many of the feelings that okay, I'm annoyed about this system, they stop using it. This is very fundamental. Okay, another one. Lego. Have you played with Legos?
No.
Yes. Excellent. Those are the best rapid prototyping tools available for everyone, anyone in the world ever. So that's the best. The simplest Lego, the basic, even the basic blocks, they are just amazing. You can build whatever you please with those. So that's if you have kids, buy Legos. Keep them, their innovation going on. And excellent tool for rapid prototyping. The whole idea of Lego is that you can actually assemble it and you can disassemble it, and then you can assemble it to another form, and then you can disassemble it. So basically, with the same blocks, you can do whatever you please. What your imagination is about. I don't like these, the latest one, the Star Wars and that kind of things. That you can do Star Wars something, but nothing else. Okay, but anyways, the Lego, and Lego has actually also their own kind of philosophy there. They have been doing educational research for a while. So that's their Lego journey map example. They like this kind of dial rings. So basically it starts where before contact travel agent, book tickets and so on until hotel coffee flights back. That kind of thing. So it's they have their own pedagogical approach on that one. So if you are into, say, or more into these journey maps, you want to know one journey map style to start, I would start with the Lego. Just for fun, because it's Danish. Yeah, and they have this serious play methodology, and there's a link for it. Okay, so instead of using those as those toys for playing, well, you actually do play. You can make animations using those simple, cruel animations, just mobile phones clicking some pictures. You can actually make those storyboards. Put Legos. You have a customer there, and maybe the service guy, then your equipment at the middle, and play the whole thing. Imagine what would actually happen. This makes also the idea tangible. It's and you'll find, especially when you're doing that kind of plays, you basically find very interesting questions usually. Okay, and there's also really good quote from Plato. You can learn more about a person in an hour of play than you can from a lifetime of conversation. So true. That is so true. Yep, but there's some links. Yeah, and there's the walkthrough with figurines. Yes, you can do this one as a storyboard or just basically walkthrough, meaning that you kind of play it, but with figurines. Like, well, the right hand side, I think those are Lego blocks. on left hand side. Maybe those are also Legos. They have been, changing a bit since 70s. Okay. Yeah, well, that's the walkthrough with Legos. Yeah. And there's a worksheets and that kind of stuff. These are actually worth of checking out what they're all about. And this is a common method for service design. This fundamentally can be used to find flaws on the services. Walkthrough. All right, then back to the engineering. All right, there is a Autodesk, which is the producer of the AutoCAD, which is the most used mechanics design program in the world. There's the Tinkercad. Have you used the Tinkercad? No. Okay, I'll show you. Since we are here. It's a simple online 3D design and 3D printing app. And let's see, well, I have an account here. I'm not sure if I remember the password, but let's see, it's either one or two. Let's see. Yahoo! I found it. Yeah. Okay. So these are my Tinkercad designs, and so do you recognize anything here? So how about this? Yeah, that's my 3D model. Very easy to use. And you can even order some 3D prints, but on the other hand, we have actually we have this printing lab. They have two 3D printers, and then on this corridor, Joe Hotchkiss, he has actually access to one a good one, 3D printers for plastic. So if you need some plastic models, say about hand size that fits into your hand, we can print it if you have the 3D design. And then there are something like 8 printers on the library. Okay. Let's for example tinker that one. So that's just an example, very simple design. So wherever you need for example, some fixture. So let's make this one a clamping fixture, meaning that actually, let me move it a little bit around. Let's see. From, did I move it somewhere funny place? No.
It works the same like SolidWorks?
Yeah, but easier.
Easier
Interface, much easier interface. Much easier interface. So basically, let's see. You. Whoa. So it has two kind of materials here. One is the solid object, and another one is whole object. So these.
2 dimensions.
Well, there are 3. There are also this kind of basic shapes, and there is a JavaScript interface. You can generate whatever you can program. But anyways, this far I haven't needed any programming. So there are enough of these basic blocks. But for example, if I would like to have let's see, zoom it a little bit in. I hate when that happens. All right. So basically, if I would like to have I know this is so small object, so it's very tiny object. But let me start with the new one just for fun. This is this is not a good examples because that's so tiny object. Let's go back to the my designs. Oops, new design. If I would like to make some picture, for example, for my bike, it goes over a for example handlebar, and just like this, with some hole here maybe, and then you need to have a hole here so that they can put a screw on, bolt it together, and for some reason you don't find that exactly that kind of thing from the shop. I will start with a solid box. For example, like that. Then I could put here the cylinder. That's just for fun. Right, let me change the dimensions a bit so that now it's 20. So diameter, for example, 11 millimeters or 10 millimeters. It's also easy to make ovals. And then basically I can take these both and I think I can align them. Align, okay. Okay, I can align them like that, and like the center of this one. Okay, didn't work that way. Align. Why it doesn't go there? Stupid program. Well, I will just move it here. Okay, that's somewhere at the middle. Maybe I should have. It should actually be a hole, total hole. But anyways, then I need to basically make a hole here. So what I can do, just make another cylinder. Take another cylinder. Make it a smaller one. Maybe say 7, 6. Oh, that's just tiny. 6 millimeters, and then make it, for example, for right, not like that. 2 millimeter wide, and then I can rotate it. Let's rotate it the correct way. Rotate it. There's 90 degrees. Oh no, actually I did. Okay. Rotate it, and then alright, let's see. Let's move it somewhere in the middle. Alright. Was that the moving in the middle? Okay. 9 millimeters, right? Okay, then I can move it actually on. Oops! Ah! What happened? Move it, move it, move it. It's a bit faster on my own laptop, but anyways. So move that one. Huh? I hate it when it doesn't do what I want it. Oh, it also changed the shape, of course. Of course it changed the shape. Maybe it actually now starts moving. Yeah, now it started moving. Okay, now I have a hole here on that one. Oops. Okay, whatever. But anyways, then I can actually combine all of these together. Okay. There. Group. And now I have a object which has a hole at the middle, and basically it also should have the hole on the side. Then I just need to make a cut at the middle. But anyhow, that's the basic functionalities are there. And well, unfortunately this computer is a little bit slow, but it was faster computer, and well, we have enough of bandwidth. But anyways, it's a good tool to design all sorts of shapes. And it also takes in, actually, if you have a 3D model made by any decent 3D modeling program, you can take that one here, use it as a part. For example, I have taken this the electronics design 3D model from the electronics design program, and I did that one to be able to yeah, there we have. I did that one basically to design these design the what I need to carve away from that plastic model. Okay. All right, so that's the Tinkercad, and that's very simple to use. Much simpler than this. What you mentioned? The what was the program you mentioned? 3D modeling program. SolidWorks. Yes. SolidWorks is good. Basically, it has been there for a while. It basically some of the Vaisala engineers used SolidWorks when I was working there, so it's the 90s. So it has been there for more than 20 years. Yeah, and SolidWorks has always been a 3D modeling.
Yeah.
Unlike Autodesk is quite new, which makes this the AutoCAD. That's quite new on 3D. They still have basically their 3D idea is to have a 2D model and layers. Until say a few years back, then they started really having the 3D models. And it's the AutoCAD is very heavy. Yeah. But SolidWorks is a good tool. I think we have a SolidWorks like the academic license here, so if you want to try it. But anyways, for those small, fast prototyping models, this Tinkercad is quite enough. It's quite enough. Yeah. Okay. There's a workshop, but we don't basically have the workshop today, since I don't see any reason to make a workshop with